What is up? So today I got a different type of project for us today, and what I'm gonna do is build an enclosure for this 3D printer. As you can see, it's the basic framing around it. So we have the frame, then we have the power source, and then we have the spool here. And the issue with this is I have nowhere to mount this, so that kind of just feeds directly down, and this kind of just sits off to the side. But if I want to move it, I have to move it like this, and then of course that's not good for the print bed because it throws it off. So I want to build the enclosure to go all the way around here, and then have the front where it comes off or it's open in the front, and then just have something blocking the front of this travel in this direction, but nothing on the top area, so that way you can see it from the front side. Maybe add some windows to the side, some glass windows, maybe a glass print bed, so that way it's easy to take off the parts. But what we're going to use is some wood to construct the outer shell, and it's going to be plywood, maybe some of the birch plywood or something where it has a nice finish to it. Cut something like that out, see what happens. I'm going to show you a model of what I'm going to construct, and then draw it out on the board and try to get everything built with the 4x8 foot sheet, and that's going to run you about $40. So if we come over to this side, you have all this wiring just hanging out here, and it's no good, especially if you got to move this, and we want to clean that up. But this printer here costs anywhere from like $400 to $600 depending on where you get it. And I got this whole printer with 2 spools of filament for $600 shipped, so that was pretty cool. This build surface is 250 millimeters this way and 600 this way, so that's roughly a 10 by 16 inch print surface, and then I believe the top is like 400 millimeters or something like that. So let's get to it, see what we come up with, and let's get to building. Okay, so this is the layout. This is the mock-up of what it's going to look like. So this is the side profile. If you were to look at it from this angle, from the front, this would be the side profile of the cabinet that's going to come off. And then if you look at it from the side, this is going to be, there's going to be 2 of these. And then if you looked at it straight on from the front, this angle, as you can see, this dotted line is this edge right here. This is the top right here, and then this right here is the 14 on facing this way, and then the base is right here, so it's going to go all the way out, extend past the actual enclosure, and that's going to house the power source and the memory card and stuff. And then on the back side, if you were to picture this in 3D, on the other side, I'm going to mount the spools, and they're going to sit low below the beam and everything. So as we zoom out, this right here is the side view, and then you come over to this side, and then this is another side view. So these are the ends. These are going to have handles probably cut into them. This is the back. The dimensions going in this direction. If you're wondering, this is 27 from the front to the rear, and then this is the bottom. And then of course this is 16 across here, and then this is 14 across here, and then that gives you your angle to cut. This is the back. It's 24 inches tall by 24 this way, so it's a square. And then it's 24 this way for the front. So the front right here, if you were to face it this way, and 14 tall. So 14 tall by 24 wide. This is the angle. So the angle that's right here on this edge should be right in there. So that's going to be 15 inches tall by 24 in length, because that's the width of our box. And then here is the top. So the top is this one. Remember, this is the side view. So it's going to be 16 inches tall by 24 wide. And then this is the base here. It's going to be 32 in length. And then the width is, of course, 27, I believe. Yeah, 27, because that's this base width right there. So let me show you it on a Solidworks model, and all this will make sense. Another thing to remember is this is a 4-foot by 8-foot sheet, and it barely was enough to create all the components that you need. This is going to be left over, and this area is going to be left over. Okay, so in order to glue all this stuff together, what I end up doing, instead of buying wood glue, I bought the liquid nails, the Fuse It edition, and it bonds to all surfaces such as glass, metal, ceramic, wood, granite, mirrors, rubber, plastics, and other stuff. This stuff's good for about 400 degrees Fahrenheit. And the Blue Label liquid nails with the little blue label that's wrapped around here, that one's only good for about 200 degrees. And this stuff's supposed to be real good for heat. So since our 3D printer is going to produce about 200 degrees to about 260 to print different materials, we're going to need something that won't let go if there's a lot of heat buildup in there. And then you want to get something like this, which is a brad nail gun, and it shoots these little thin nails into your wood. And the cool thing about this is once you glue, like say a panel, you don't want to hold it or you don't want to tape it, so you just take this and then staple a few of these into the side of the wood, so that way it holds everything together until this cures. This you could pick up at Harbor Freight for about 30 bucks, around that vicinity, and you could use it for all your wood projects. So it's a pretty good tool, good to keep in your toolbox. So once you have all that laid out, your wood cut, now it's time to assemble. Let's get to it. So here's the progress so far. I didn't do all the steps and show you guys because it's basically self-explanatory once you see it. I kind of got you started to see the direction I was going. The platform that stuck out on the other side, so this was a full piece here and it went all the way that way. I trimmed it off because the wires in here were too short to go all the way to the other side, and I didn't want to splice it. So since this box is temporary and I could always replace it, I decided to trim it with the skill saw and then use part of the base on this side, and I made it the size of this box. The reason why I had to switch it from the left side to the right is because originally I wanted the SD card to be accessed on this side of it, but since the wires are short, I put it here and I added these sides all the way around, so that way it holds this and it pushes on the screws, so it kind of keeps some friction on the power source. But I'll just slide it forward, access this SD card, and then for storage push it back and set it in. And then on the back side I also have a hole. I think it's a 1-inch hole. I used a hole saw and just cut it all the way through, allowing the wires to enter and keeping them from having to fish all the way up and over. So in order to mount these strips after they're cut to size, I drilled it with the largest drill size I could without touching the wall of this on this side and without touching this lip here. So I drilled it out and then I drilled a smaller hole there, so that way I can mount a screw all the way in, and I pre-pilot it all the way into the wood so I didn't split the wood on the edge. And I put a screw there and I put a screw on top, and this isn't going anywhere. It's really sturdy, and all it does is hold the plexiglass, so that's what holds that together. Okay, so I ended up purchasing these binder clips It's a variety pack. These are the minis, not the micros. The micro would fit, but it would be a strain on the glass since they would be opened up about like that. So these are the minis. If you get the variety pack, you get a whole bunch of different sizes. So whatever works best for you is what I would recommend. And then what I ended up doing is buying this L bracket from Home Depot. And since this is a 5-inch L bracket, the spool here is 8 inches in diameter. So half of that would be 4. So 4 inches would put you down to the bottom of this. So 5 was perfect as far as height. Then I bought these clips right here, or these are for a rack. So when you go to the gym or whatever and you're bench pressing something, these go on the end of the barbell itself and they slide over the 2-inch shaft to hold the weights in place. I picked these up for $10 for 2, and they got a rubber insert, so once you slide them over you can lock them and it holds whatever you have them slipped over in place. So I did that to hold this spool on the shaft here. I used a 5/8 bolt and a washer in there. This is 2 inches in diameter. I made this, and then it's 2.5 inches diameter on this outside to keep it from sliding in this direction. And that pretty much holds my spool in place and it free spins. Then I bought this camera here, and this camera is a YI camera, and I'll show you how that works. Then this is the AFO fire extinguisher ball, and this is self-activating. You can lift it up and take it out and use it elsewhere, but just in case there's an electrical fire, this will put it out. This was like, I want to say $39 on Amazon, I believe it was. And it's just extra precautions, so when you're not around your 3D printer, you know that it's pretty much safe. It's this bracket right here has only 2 bolts going into it that way that mount to the wood and hold this in place. So in case of a fire, there's like a fuse that goes all the way around it. So let's see. So right here there's a fuse, and it wraps all the way around the ball, and once the fire hits it, it ignites this and sends powder all over your stuff and kills the fire pretty much instantly.